Well, hello friends. Welcome back to OS haxx0ring. So today we are going to take a look at a security problem I found in Serenity, and then we are going to write an exploit for it, try to get root access, and finally we are going to fix the security problem. So the whole gamut. So let's start by taking a look at the security problem. So a while back, we added shadow passwords to the system, right? So the user accounts are an etc password, and then we also have a shadow file that contains the password, and the shadow file is not writable by anybody but root. So basically the same system as other Unix variants, and obviously I can look in password but not shadow. But when I use the password command to change my password to hello, then it actually does update the shadow file. So you can see here that it was actually written and updated. And this works because the password program is setuid root. So if we look at that, we can see that it is setuid root, and it runs with elevated privileges in order to update the password and shadow files. Now, the security problem here is that when we are updating the shadow file, what we do is we use this class called core account, and let's see, where we generate the password file and generate the shadow file, and then we have this function called account sync, where if you've made any modifications to the C++ account object, then this is where those get written to disk. And what we do here is that we generate the password file and we generate the shadow file, and then we write them out to disk. But you'll notice that we write them out in two steps. So first thing we do is we truncate the existing file so that it's empty, and then we write out the new contents, both for the password file and for the shadow file. And I realized that this has a fatal security flaw, right? Because what if somebody were to come in right in between the truncation and the write and look for their password in the shadow file, and then there wouldn't be any password in the shadow file because it's empty, and if it's empty, that means that it's a passwordless account and you can just log in. So that seems like very exploitable. So that's what we're going to try to exploit first today, and then we'll look at fixing that once we have used it to gain access. So yeah, I think this is a pretty basic like Unix system race condition. Pretty classical security flaw, and I walked right into the trap like so many others have, and now we're going to make good by first exploiting and then fixing. Okay, let's start by making a new hack program. We'll call it haxx.cpp because that is my favorite name for exploits. Oops. Haxx. Okay, so what does this mean in practice, though? In practice, it means that when we're syncing out an account object to disk, we have this tiny window of time here where we need to come in because the password file or the shadow file will be empty. So I'll show you actually what happens if the shadow file is empty. Well, actually, by default, the system doesn't even have a root password. So let's add a root password so that we can test with that. Let's see. So let me just, I will just copy Anon's password, which is foo. Oops. root. All right. Oh, and then I have to add a main function to my haxx program. Okay, so now root has a password. It is foo. But if we were to just, remove etsy_shadow, then then it's very sad. But if etsy_shadow is there, but empty, then we can just become root because there is no password for the root account. This is probably not ideal. Like maybe we should refuse to log in as root if there is no entry for root in the shadow file. But ignoring all of that stuff, let's just hack into the system. So we'll want to set up the situation where the shadow file is empty so we can just su our way to root. So let's get some things that we might need. And I don't know, a little bit of this and that. Okay, so I think what we want to do is if we look at the workflow here, so basically when I write password and I type hello, after I press enter, at some point after I press enter to the program exiting, there was that tiny window of time where the Etsy shadow file was gone, right? So I want to somehow catch that moment in time and not necessarily run a program at just that time, but actually if I'm just thinking, could we make that moment longer? And I think we can just stop the process, actually. If we just stop the process when that truncate happens, then we have infinity time to SU, actually. So we don't need to race the truncation with an exec, but we can race it with a signal. So let's do that. Yeah. So let's see. Let's see. Child PID is fork. So let's make two processes. And I think what we want to do is we want to set up a pseudo terminal where we execute password over and over, giving it some input, and then after we give it the input, we just try to stop the password process, right? And every time that we try to stop it, we can just check if the shadow file is empty. And if it is empty, then we're good to go and run SU. So that's the plan. Let's try to do that. So if no child PID, then we are in the child. Okay, and then we need a pseudo terminal actually. So master pseudo terminal is going to be POSIX openpt read write, and we need printle. Alright, and then this isn't really something that you do very often, at least I don't, so let's see, how do we do this? We have it in the master, and then we need the slave name, which is the PTS name of the master. Actually, I guess if this fails, we can bail out. But obviously, we don't have to be like the most diligent about handling every possible error here. Just some of them. So let's see. So maybe we'll wrap this in a function actually. Attempt. and then we can loop that and stuff if we like. Something like this. Okay, so we fork. Actually, let's open the thing before we fork. Obviously. So now we have the master open. And we have the name of the slave, so we need to open the slave. Although I guess we only need to open the slave in the child process. So slave fd is open slave name, read write, and we should be good. Okay, and then now we have to do all of this stuff to move everything in the child process over to the slave pseudo terminal. So like we need a session, and we need to move all of the standard input, standard output, and standard error. We'll just move them over to yeah, like this, right? So we take over the standard streams with a new pseudo terminal, and then we will we want to make it the controlling TTY of this process. I think it's like TIC set controlling TTY. Is that enough? I mean, that might be enough. Okay, and then we want to set the process group to the current PID. All right, that's a mouthful, but I think that's sort of what we do in terminals and stuff like that. I'm not entirely sure that this is correct, but we'll see. I mean, actually, let's do this so that if something isn't right, then we'll at least get some error message. Yeah, we'll do this. This will be good. Okay. There we go. Hopefully none of these show up. And then once we've done all that, then we want to exec, right? So exec lp bin password, and hopefully we never arrive here. Okay, so this is what we'll do in the child process. So we'll just open a pseudo terminal and set up the slave TTY so that we can run password on it, and then what we're going to do in the parent process is we're going to feed keystrokes into password. So now we're in the parent. I'll just write this out for clarity here. Okay, so we're in the parent process, and we want to, I guess we can sleep a bit just to let things wake up. It's a little cheesy, but just wait for password to start up. We can do something nicer, but we'll do the sleep it first. Okay, and then we want to, I guess, fetch the prompt that it gives us, because when we run password, it's going to give us a prompt. Right, so we have to read this stuff from the pseudo terminal. So we'll just make a, I don't know, like a little buffer here, and read from the master foot. And actually, I think we can close the master here. We don't need the master and the child. And once we have dumped the slave, we can close that as well. Down here, after we're finished with it, because now it's open as standard in, out, and error anyway. Okay, and then let's see. So we read from master into buffer. Maybe we'll print out what we read. Read from passwd. Buffer. Okay. And of course, if that fails, then sad face. And also, that's not how printf works. Okay. And then, after we read this, we want to send keystrokes. So we can just say like const char new password is keystrokes, let's say, test new line. Yeah, so test will be the new password. Or you know what, we can put anything we like, so let's just put this. Okay. And then we will write this. New password keystrokes, low size of, new password keystrokes. Or wait, hold on, no, I just want to send this to LAN. I don't need the null terminator. Okay. Write to password, read from password, let's say. Okay, so after we send password, then, wait, what do we want to do then? I was thinking, do we need to wait on password? But then, basically, after we send the password, that's when we can start, maybe we want to sleep for just a moment and then start harassing it with signals. So we'll sleep just like 1 millisecond, and then do something like we kill the child PID with 6 stop. Yeah. We'll stop it and then continue it. That's the easiest way, I think. Okay, so yeah. So if this fails, then I guess that means that the process just died, which is okay, because then we'll just loop around and start over. So actually, we'll just break. If sig stop fails, that means the process basically wasn't there probably. So we can just break out of the for loop and then start over. So I think here we'll just close the master FUD. Do we need the master FUD actually after this point? I guess we don't, so we can just close it up here. And yeah, although I'm hesitant to put it here because this is like our window of time, right? So we wanna be strict about that. So we'll close when we're done. Sigcont should succeed if stop succeeded. So kill cont, let's say. All right. So then what do we do? I guess, okay, so we've stopped the password program. So now we just have to check if Etsy shadow is empty. So we'll need stat. Etsy shadow. I don't know why this would fail, but let's log if it does. Okay, and then if st size 0, then we have successfully haxed it, right? So hx. Yes, something cool like that. Very, very cool. Okay, and then if that works, then we should just be able to run SU and get a root shell, I think. Yeah, so let's try it. I'm probably doing something stupidly here, but let's see, close, and then this will just return when we get to another attempt. Okay, and then let's see. Let's just print out like a dot or something every time that we do an attempt. So that we see if this is actually working at all, or if we're like making multiple attempts. Okay, so that didn't quite work. Alright, so we did one attempt, and then kill can't failed, no such process. Read from password, blah blah blah. Oh, wait, I guess these are jumbled because of the lack of new lines. Okay, so what went wrong here? Okay, so we read this from password, that's good. And then presumably we write this successfully. Killing it with stop doesn't fail. But then doing the can't fails. Does that make sense? I'm not really sure. But what if we just report this and don't actually exit on it? Because I don't know. Okay, so now it's trying a lot of this. But it's not quite working. Oh. Okay. Still there, still not empty. Alright. So let's see, how can we improve this? It's like sleep here is obviously slowing us down, right? So instead of doing that, let's just set up some shared memory that we can look at from both the parent and the child. So let's see, we'll do something like this, like ready. So we'll do one page of memory, prod read, prod write, map anonymous, map shared. Yeah, and then if ready is map failed, then error, a map. Sadness. Alright, and then we just say like ready is false before we fork, and then just before we exec in the child process, we will say ready is true. And then here we can just say like while not ready, right? Because it's volatile, so we'll just actually spin loop. And then we don't have to do that sleep. Okay. Still a bit sluggish. Let's see. So let's not print out on the standard output. And let's just not print stuff out other than the dots. Oh! Ooh! It worked! Look at that! Oh man. Yep. I am root. Okay. That's how you do that. Wow. That was surprisingly easy actually, but I mean the bug was kind of obvious. So once I realized what the bug was, then it was kind of obvious how to exploit it, but still though, that's funny. Wonder if we actually need this sleep here. I guess we did not. Oh man, that was really, really easy. So even without the sleep, it's even faster. Okay, so look at that. That's wait, but we're not printing out my cool haxx prompt. What the heck? Forgot about that. It's supposed to show this cool prompt. There we go. Now it looks like a real exploit. Nice. Okay, well, I guess I'm not really eligible for a bug bounty here because I caused this bug. So, also I would have to pay myself, which would be silly. But instead I have to pay for this by fixing it. So, what are we going to do about this? I guess, actually we can take off the hoodie and get to work on fixing instead. So, let's see. So the account object, and let me get a little more light. Okay. So this truncation thing here, obviously, this is screwing us up. So what we want to do is we want to atomically replace the files. So instead of truncating and then writing out the new content, we want to write to a separate file, and then once we've written out the full new shadow file, then we replace the existing file with the new file. And then there's no moment in time where etc shadow is empty. I think that's the approach here, and we'll do the same for both of these two. So this will require some rethinking of the password program, because currently it unveils only etc password and shadow and group as writable, and then it sort of locks itself out from the rest of the file system. But what we want to do is we don't want to write directly to these files anymore, but rather we want to write to a temp file and then do a replacement, but we want to do the replacement atomically, so we have to use rename, and that means that we can't just put the temp file in like /temp, because that's a temp file system, so you can't do like a cross file system rename. So I think we have to put the temp files in @c. So maybe what we want to do is just say that @c is writable. So we will unveil @c with rwc. Yeah. And then we also we have to keep the cpath pledge promise, I think, because we'll need that to create the new file, create the temp file, and we need it to do rename as well. So we'll hold on to the cpath promise. That's like creating new things in the file system. Yeah, so we keep cpath all the way to the end. Okay. So I think that part is fine, and then when we sync, so oh man. I didn't even notice this fix me I wrote. Maybe reorganize this to create temporary files and finish it completely before renaming them to @c password and shadow. If truncation succeeds but write fails, we'll have an empty file. See, I was like, I had a hunch, but I didn't realize that, I didn't realize how exploitable this was, I guess, so I just made it a fix me. That's so silly. I bet you can even, I made this in a video, so you can probably even like watch me introducing the bug and like typing out this fix me. Well, let's reorganize this as the fix me says. So what does that mean? I guess that means that there's no huge value in keeping these files open, actually, because we're going to use rename to replace them anyway. So yeah, we can reorganize this class quite a bit based on this. Okay, so here we have the content for the new files. So we'll write those out to disk. We'll start by just saying like password temp file is core file open. Or wait, should we use some like mks temp thing maybe? New password foot is mks temp. Is this how this works? I forget. mks temp should give you a file descriptor. mks temp. Wait, what does that do? Okay. So this sounds very reasonable, right? Like mks temp creates a temp file name with the pattern and then opens it with creat and exclusive, right? So it means that we avoid this race, because if we open the file and we were not the ones creating it, then the open will fail. So I think this is good. And we'll also do new shadow foot. And why are you complaining about this of all things? Oh, right. Okay, fine. Has to be a mutable string. That makes sense. Because then we learned a new name. Okay. I have not used mks temp in years, so this is good. A little refresher on Unix libc basics. Okay, so if either of these open calls fail, then, you know, then let's just bail. Or let's just assert not reached, actually. So we're sure as heck not going to write to, try to write to one of them but not the other or something like that. That would be not very good. Okay, and then we can just write out the content, I guess. So, write new password fud, new wait, oh, we have, they're called file here, that's kind of misleading, so like file content, let's say. Okay, so new password file content, characters, new password file content, length. So let's see, if n written is less than 0, then yeah, I think we'll just fail in this way for now. Okay, and then we'll also write out to the other one. Oops. Excuse me. Suddenly had to sneeze there. And then let's just assert also that we wrote the whole file. These things should be cleaned up to not just be assertions, but like something more graceful. But for now, assertions are fine because we just need to crash the program, right? Not continue past that point. Okay, so these should be shadow fud, shadow file content. Okay, so after this point, let's make sure that we clean up everything here. And let's see, we can even make some scope guards. New password foot guard. Yeah, I just like to close things in this way so that when you have many different many ways to return from a function, it's nice if you don't have to repeat yourself and say close everywhere. So we'll just make these little scope guards to take care of that. Okay, and then we exit the scope and we've closed those things, and now all we have to do is to rename those two files. So actually there will be a window in time where we have replaced the shadow file, or the password file, but not the shadow file yet. So that is a bit unfortunate. I'm not sure what exactly the solution is for that, but it seems like is it actually necessary to edit both at the same time? I feel like when you're changing your password, you really only need to update the shadow file. So yeah, so maybe it doesn't actually matter in practice. I was just thinking, like, could they get out of sync? And I think we need to improve this thing I mentioned earlier that like if we're looking up the password for a user in the shadow file and he's not present in the shadow file, then we should fail the lookup instead of assuming that it's a passwordless user. Like passwordlessness should be explicitly specified in the shadow file, not implied by the absence of an entry. But even so, I think it's good that we fixed the truncation race here separately from like changing the behavior of the shadow files. So now we just need to rename. So we rename the new password name to etc password. If that fails, then we will warn failed to install new etc password. Actually, this is a great place to use pair. Okay. Will this work? Guess we can do this. We can bail if either one fails, and we'll leave a little bit of a mess here. But I think if we fail for some reason and we leave those temp files in etc for the admin to clean up, I think that's better than like getting into a bad state and then trying to remove files. Like I'm not sure. So password hello. Okay, so that went bad. We aborted probably because of pledge. Has not pledged our path. Oh. Wait, why? Why did we die from that? Calling stat. Wait, where are we doing a stat? Who's calling stat? Require promise our path. Oh, I mean, I know that it's a stat, but. I didn't feel like I was making any stats. Okay, so also we don't need to seek the files here, by the way, since we're writing new files. Oh, MKS temp, I guess it's doing stat. Generate unique file name. Yeah, right, so it uses, wait. Oh, I see, so, like, it does a stat in the loop. So I feel like you could combine this into not doing stat and then open, but like doing attempts with open. But let's not do that right now. So I guess we'll just add the rpath pledge promise. But it would be a good, I think it would be a good improvement to make MKS temp use only open and not stat, because then you could live without rpath. I think, at least. Okay, so password. Hello. Aborted again. Why? Has not pledged wpath. Oh, dang it. I need wpath to create a new file? I thought cpath was enough, but oh, I guess it's not. Oh man, we're just adding more and more stuff here. So we need, what do we need cpath for then? We need cpath for unlink, rmdir, rename, open with creat. Oh, I see. So creat can, if it's creat then you require cpath, but if it's if you're opening for writing, you also need wpath. So we need both cpath and wpath to create a new file and write to it. That's fair enough. Alright, so now we have something new to look at. Assertion failed on 293. So mks temp new password name fails. And why? I guess we should inform ourselves about why. Permission denied. Alright. So e-access, I guess, right? E-access. Which call is failing at the access? Presumably the open. So let's go to etc and see if we can actually make a file ourselves here. So touch shadow x. Right, so we're totally able to do that. Also, we need to make sure it's not world and group readable when we do the create here. But we should totally be allowed here. Oh, wait, shit. Have we dropped privileges? Oh, I think we have. Yeah, we drop privileges after opening the files. Yeah, so we can't actually do that anymore if we want to create a new file in etc, because etc is only writable to us when we are the root user. So, that's a bit sad. Maybe there's a way to do that, but like that would require some rethinking. Okay, so no complaints. Password is there and shadow is there. The other files are gone. That's cool. So did the password stick though? It did. Okay. So let's see. I am curious now about the we need to look at the file permissions in the time window here where these temp files exist. So before we actually do the rename, let's go to artificial sleep, just so that we can take a look at the state of etc before moving the new files into place. X. Alright, so etc looks like, here's the new shadow file, and here's the new password file. They're owned by anon and users. That doesn't seem quite right. We should probably fix that. Wait, why is it like that? Well, are we now? I'm not sure about this. Like, if we're running with a elevated effective user ID, are we supposed to create new files owned by the effective user ID? Because that sounds kind of sensible. But I'm not sure. I don't know, let's see what Linux does. Let's make a little test program. Okay, so let's use the same toys. So yeah, so we'll do this. And then okay. And we'll write something to it like hello. Something like that. I don't know. And then oh, we want to do this first actually. Okay, so now we have this file. It's set UID root, and if I run it, it created the file owned by root with my GID. With my GID. That's not exactly what I expected. Wait. Let's print out the effective group ID as well then. Let's see what that is. Okay, so the effective group ID is still 1000 because we only elevate the, I mean it's set user ID, right? It's not set group ID. So what if it were both? Like if it were set gid set uid? And we should run with 0, 0. And we do. And the file created is 0, 0. Okay, alright. So when we create a new file, we should actually use the effective user ID and effective group ID, not the real user ID, real group ID of the process. So that's a flaw in our file system implementation, but we can go and fix that. Let's see. So optional UID and GID. Right, so open takes an optional UID and GID, but if you don't specify which UID and GID for the thing to be owned by, then we'll use the default values somewhere. Let's see. So here, for example, current process UID, current process GID. I think maybe we just need to change all these to EUID, EGID. Create. Owner has value. Right, so if something is specified, then we use the provided. Otherwise, we default to the effective credentials of the calling process. That makes so much sense. I am glad that we are fixing this because I didn't think about that at all. Wonder if that was exploitable somehow. That would require some thinking, but let's not get sidetracked with that issue. Instead, let's just patch it up. Symlinks, reduce the... Yeah, of course. Yeah, okay, so that's good. It's very, very good. Let's see. let's look at Etsy now. Okay, so now we have root users, yeah. So since the program is set UID but not set GID, it doesn't actually update GID, but I think that's okay. We don't need to set GID the program. And in this case, like, the group ID is meaningless anyway since it has no added permissions. So that's good. This seems like a decent state. There's nothing here to do, right? Like there's no, this is not raceable, I think. Readable by user, writable by user, and that's that. Is there a UMask to care about? I'm just well, it seems to be working. Good. So, let's see if our exploit still works. Oh, haxx. Something crashed. Oh. It seems like we have crashed crashed the kernel. Write block failed. Okay. Don't know what that is. So we crashed a password program in a port. Interesting. Let's see, resuming. Maybe if we don't log this, we can see a bit better what's going on. It seems like we are managing to hang the kernel instead, which I'm going to call that a separate issue. Now it's a local denial of service instead, but we have plenty of those, so it's not like that's a huge surprise. But yeah, so now we get into some kind of failed I/O problem in the ext2fs implementation. Right here. I don't know why that fails. Let's see if we can get a backtrace. I'm just curious what we're actually up to when this happens. Maybe it's when we're doing a file system sync. And then that just can't handle the failure. Why would it fail though? Oh, okay, so we're just completely frozen at that point. Well, I'm not gonna debug that now. But I'm just thinking, what can we do to, if we just like put a sleep back in, does that make the problem go away maybe? Because I guess now we're hammering it really, really hard. Okay, well, I don't know, but we have probably exposed some other issue instead. Looks like so let's see what happens if we, oh, now everything is all broken. Okay, so now that we're in this state, these files are good. Okay. Yeah, well, we can't fix every bug, but we can make the architectural fix here to the password program. And we can also fix that effective user ID thingy. So, okay, now we have patched up etsy password. But see, now this is not good because now it ends up, the password file ends up not readable by world, and we only wanted that for shadow. So now we've made a mess and we need to fix it. So I think before we do any writing out here, actually, let's fchmod the new password file. Do we not have fchmod? I'm pretty sure we have fchmod. Yeah. New password file. And you will be 0644, my friend. Yeah, so it's going to be group and world readable, which is exactly what you want for Etsy password. Without that, that would be a bit messy, and now we also need to pledge fattr. Yes, fattr. Sure, fine. That could also be avoided if we have a better API that allows us to MKS temp with a mode, which they don't have here. Mode. POSIX 1/2008 adds requirement that the file be created with mode 600. Right. So yeah, so in our case, I guess we can trust it to do the right thing, but it would be cool to have a variant of this, maybe, that allows you to specify a lax mode, and then we wouldn't need fattr, but we can keep fattr for now. Yeah, so we're loosening it up a bit, the password program, in order to fix the race condition, which is unfortunate, but it's not like it's finished. Okay, let's see password, looking good. Let's see shadow. Actually, you know what? Let's make them. Let's fix the group so that it's not a nonce group, because that's a bit weird. Then we'll need fchmod. Oh, I mean, we already have fchmod. We want not fchmod. fchown. Alright, 0, 0, yeah. Maybe we'll do all of this stuff after opening before writing anything out. It seems slightly better. This code is very C-ish. I'm just doing it at the lowest level right now because I don't want to. I don't want to screw it up. So we can probably abstract this into like slightly nicer flow so that it doesn't have to be so verbose. But for now, I think this is okay. That was aborted because of has not pledged chown. Well, we are just gonna pledge everything, aren't we? Totally forgot about chown being a pledge of its own. So is it better to pledge chown or to be set GID root? Actually, what if we don't do that? Can we just set EGID? And then we don't need to do the chown at all. Let's see. Can we just do that? Then we don't need to pledge id. Okay. No, not haxx. Password. Aborted, right, because we're still trying to chown, but I think now we don't need to chown because we just set the effective group ID and then these boys no longer needed. Okay. Yes, and now everything is root. Okay, so that feels like a decent solution to this. So let's see, kernel, file system. Let's add all of these changes here that use the effective UID and GID when creating new files. Create new files with the current process UID, EGID. Using the UID, GID, and not the UID, GID, which didn't match other systems. This was probably exploitable somehow. Well, we didn't look into that, so let's not exaggerate. And then, oh, that was just silencing a comment temporarily. I'll just get rid of that one. And then all of these changes to password and core account. Yeah, so there's going to be more work on the password program because now it's actually no longer necessary to keep the password and shadow file open like we do. The reason that we did that, as I talked about in the video where I worked on that last time, was just so that we would be able to drop privileges and still have those files open. But since we can't do that anymore, because then we wouldn't have a way to replace the files, now we had to actually stay with running as root and allow write access to etc so that we can create those temporary files and then atomically move them into place. We could probably come up with some kind of system call that would achieve all of this atomically with less privileges, but it's something that I don't have an obvious good idea for that right now, so it's something that we have to think about. What would be a good system call for that? But in the meantime, I think this is pretty good. So this is a good intermediate step. So let's see, password plus libcore. Make password replace etc files atomically. Before this patch, we had a nasty race condition when changing a user's password. There was a time window after truncating its shadow where the time window between writing out its new contents, where you could simply su to root without using a password. reorganizes. Actually, oh, there was a fix me. We can remove the fix me, but yeah, yes. Reorganizes. This patch makes us instead of writing directly to etc password and etc shadow, we now create temporary files in etc and fill them with the new content. Those files are then atomically renamed to etc password and etc shadow. Yes. Sadly, this fixing this race requires giving the password program a lot of its a lot more privileges. It's something that we can improve over time. This is something we can and should improve upon. Yes. Okay. So, I think that's pretty good. I'm a little bummed that we're not crashing the kernel with the exploit, but that's just a separate issue. I don't know what the heck. Right block failed. Like, why is it even failing? What is the error? Let's at least see what the error is. -4, alright, and then errno numbers. That's e-enter. Okay, so wait, so we're doing a write bytes, and that fails because it's interrupted. So I guess I mean, that's kind of annoying. Are we flushing? I almost feel like there should be somehow some way to sometimes say that this particular thing cannot be interrupted by a stupid sig stop, right? Like allowing sig stop to interrupt the kernel from doing a write block. I don't know if that's good. Like maybe we should have sort of cancellation points or something for signaling like that, so that you can cancel in file system operation, but you wouldn't cancel right in the middle of it, but rather you would allow the current operation to finish, and then cancellation would happen. But I think this is a bigger issue that we're not going to get into right now. At least we fixed the easy way to get root, so that is very good. And I'm going to keep iterating on the password program, making it better, but this will be the end of today's video. So if you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting here today. I really enjoy making these types of videos. It's just, you know, they don't happen super often because they require a fun, exploitable bug. So I hope you liked it. Yeah, thanks for hanging out. I'll see you next time.